Welcome to qnawire.
Okay, well, speed of sound can be equal to square root kRT. K is the specific heat ratio, R is the gas constant, T is the temperature. So let's assume that refrigerant 134A is an ideal gas at a room temperature. So therefore, we have the specific heat for the refrigerant 134A is 1.108, and the gas constant for the refrigerant 134A is 0.08149 kilojoule per kilogram times Kelvin, which is 81.49 joule per kilogram times Kelvin. And we know the temperature is given as 60 degrees Celsius, which is 333 Kelvin. So now let's plug in Betzel equation to determine the speed of sound in refrigerant 134A, which is equal to square root 1.108 and then times 81.49 joule per kilogram times Kelvin, and then times 333 Kelvin. And this will give us the speed of sound in the refrigerant 134A is about 173 meter per second.